We're doing part 2 of problem 4 in Novice Workbook Mod 7. Again, we're working with optimization, and what we want to do now is answer some sensitivity analysis questions related to problem 4. So let's go back to our problem, and I'd like to deal with questions B, C, and D. The first question says you discover that you actually have more of resource C than you thought. You got 460 units rather than 360 units. Are you happy about this? Well, we define happiness in many different ways, but in this particular case, does it really matter to you? Are you happy that you discovered, some money under the sofa cushion, or is it, inconsequential? So let's take a look at resource C in our solution. Here's the information that we got from our sensitivity report, which was produced, and I grabbed this information, I copied it, and I pasted it into our solution. And we can see from the solution here that we have the resource constraints here, and we want to know if the resource constraints are binding and non-binding. A resource constraint is binding if the left-hand side is equal to the right-hand side. In other words, you've used all of the resource available. In our case, resource C, it's not binding and the slack is 200. In other words, I thought I had 360 units of resource C. I actually have 460. But for the 360, I've got slack of 200. In other words, I only used 160. So I've got stuff left over for that resource. So the answer to the question should be fairly obvious, and you're not happy, or this doesn't make you sad necessarily, but there's no value in receiving more of a resource that's not fully utilized. It's a non-binding constraint or not binding constraint, and there's slack, there's left over. So why would you rejoice in having more of something that you already have too much of? Let's look at C now. Question C, is there a resource, A through D, that will be of value to you, to the objective function, if the right-hand constraint can be increased? So it says, okay, well, is there anything that's going to make you happy? So let's look at our constraints again. There is one binding constraint here, that's D. So it is a resource that if we had more of this, we would probably make more money. We would make more money. We'd add value to our objective function as a result of that, because we're up against the edge of our resource. So if I had more resource, I'm going to make more money by selecting more projects. So what's the benefit of that? Well, the benefit of that is the shadow price, which is associated with a binding constraint. Only binding constraints have shadow prices. The other three constraints for resources that were non-binding have a shadow price of 0. So a shadow price, or a dual price as it's sometimes called, dual, D-U-A-L, price, or a shadow price, is $5,500. So what that means is that for every unit of D that I can add from 285, let's say, to 286, that will result in a benefit of $5,500 to my objective function. If I had 2 units, that would be 2 times $5,500, or $1,100. So the answer to that question is yes, resource D is binding, and if you increase the right-hand side by 1 unit, it has a value of $5,500 to the objective function. So only when you have binding constraints do you have value if you add to the a unit to the right-hand side of the constraint. Dual price, not pros. Now let's look at question D. Is there a reduced price in the sensitivity report that has a value for a variable that is 0? In other words, do we have a variable that suggests that we did not select any of that project? And we know we did. Our fourth variable was a 0, and so it is going to have a reduced cost. Remember, reduced costs are the value associated with increasing the coefficient, the current coefficient of that variable in the objective function. Currently, the coefficient of the project value 4 is 19,500. So for every project 4 that I accept, I'm going to get 19,500 units. But we're currently at a value of 0. In other words, the solution selected none of these projects because it's just not worth it. So what would it take to make it worth it? Well, what the reduced cost tells us is that if I could increase 19,500 by 2,500, if I could increase it, it's $2,500 too low for it to have any value. But if I could increase it to by 2,500, in other words, 19,500 would go to 22,000, then project 4s become attractive. So yes, project type 4 is not in the solution, but if the objective function is changed from 19,500 to 22,000 and slightly more, because that's 22,000 is the point at which we begin to think about it. So if I 22,001 or 2 or 3, then we will produce some of project 4 in lieu of producing some of the other projects. We will give up some other projects and say, now it's worth producing that project. So these are some of the interesting things we can do with sensitivity analysis. We've got reduced costs that are associated with how we'd have to change the coefficient of an objective function variable to make it attractive to have that variable in the solution. Currently it's not. We've got shadow prices. If I could increase the right-hand side of a binding constraint where I've used up all my resources, what would be the value to me? And we found we had only one particular right-hand side constraint for D that had a shadow price. So by increasing the final value from 285 to 286, the right-hand side constraint, then we know we can achieve a $5,500 increase in the objective function. We're at the maximum. The final value is 285, and the right-hand constraint was 285, so it's a binding constraint. It's holding me back. That's the end of part 2, problem 4, mod 7.